Now this is another example under logarithmic decrement. We're told to find the damping factor of a vibrating system which consists of a mass of 3.5 kg, a spring of stiffness 2.5 Newton per millimeter, and then a damper of damping coefficient 0.018 Newton per millimeter per second. We also expected to find a natural frequency of damped vibration. Okay, so the first question was to find the damping factor. Now, this damping factor is given by C, which is the damping coefficient, over 2m then omega n. Okay, so we've been given mass, we've been given stiffness, so we can convert it to Newton per meter. That's 2,500. We've been given C, damping coefficient, so we can also convert it to Newton per meter per second, and that is 18 Newton per meter per second. Now, our natural frequency is square root of S over M, where S is the stiffness, and stiffness is 2,500. All over mass 3.5, and so the natural frequency is 26.72 rad per second. Okay, so now we have the natural frequency omega n. We know this, we know the mass, we also know C. So now substitute into the formula, and then by that we are going to have a damping factor, which is 0.0962. Okay, now the next question says we're expected to find the natural frequency of damped vibration. Okay, so the natural frequency of damped vibration is omega d, omega sub 3d, which is equals to omega n, which is the natural frequency of, that's the natural frequency of undamped vibration, square root of 1 minus damping factor, square root minus square of, that's square root of 1 minus square of the damping factor. Okay, so now we already know the natural frequency here, which is the natural frequency of undamped vibration. We know it. We also know the damping factor. So by the time we substitute, eventually our natural frequency of damped vibration is going to give us 26.596. Okay, so now the third question, actually this is a complete question. Okay, so the third question now says we are expected to find the ratio of frequency of damped and undamped vibration. Okay, so now the damped vibration over undamped vibration. Okay, so damped vibration is given by omega d, undamped vibration is given by omega, that's undamped vibration is given by omega n. Okay, so omega d, we already know the formula. This is the formula. Okay, so all over omega n, so omega n cancels out. So all we just need to all we are left with is square root of 1 minus damping factor squared. Okay, so we already know the damping factor, we substitute, and eventually we get the ratio as 0.9954. Okay, so now the fourth question says we're supposed to find the periodic time of damped vibrations. Periodic time of damped vibration. Okay, so now this formula. Periodic time of damped vibration is given by 2 pi over omega d. So omega d is calculated already, and that's 2 pi over 26.596, and that gives 0.2362. Okay, quite easily done.